Farming is the backbone of the African economy. Looking at our case study for this project, Tanzania's agriculture contributes 28% to the GDP, employs 65% of the workforce, with a majority of these workers living in rural areas where agriculture is their primary livelihood. Farming in Tanzania is already a difficult endeavor, with unpredictable weather patterns and soil degradation, fertilizer and pesticide challenges. Farmers shouldn't have to overcome financial barriers as well. But sadly, financial barriers limit farmers in Africa from scaling their businesses. Access to credit is essential for farmers to invest in high-quality seeds, fertilizers, and modern farming techniques. However, traditional banks hesitate to provide loans to farmers due to the high default rates and the informal nature of their transactions. Most farmers use cash, which leaves no financial records to assess creditworthiness and difficulty in assessing loan amounts. As a result, only 3% of Tanzania's agricultural households have access to formal credit, making it nearly impossible for them to improve their yields and income.
Our solution is a remote sensing recommendation system that helps farmers make data-driven decisions by analyzing soil quality, moisture levels, and weather conditions. Using satellite imagery and spectral analysis, we determine the best crops to plant based on soil and nutrient composition. This allows financial institutions to use the same tool to better assess loan applications and loan amounts by predicting things like expected inputs and expected yield. For each recommended crop, the system suggests optimal seeds to use, appropriate fertilizers, yield amount, or agricultural output, expected revenue from harvest per acre of land based on market prices. At the core of our technology is spectral analysis, which measures how different soil components absorb or reflect light at specific wavelengths. By analyzing the unique spectral signatures of things like organic carbon, phosphorus, and water content, we can accurately measure soil properties of a particular area and recommend the most suitable crops, all made possible with satellite imagery and AI.
We'll log in, and at first glance, the home page will be greeted by the most popular produce, of course, and their current market trend. We can also check the weather for a particular location, for example, Addis Ababa. We can pick a date, we're going perhaps from January 1st all the way to, let's just say, June 30th. And we can see how the weather has been going so far at Addis Ababa. We can also see crop price trends. These are the most popular crops in Tanzania, and so we can pick a particular date as well and go all the way to perhaps maybe June again. And we can see crop price trends, which have been relatively stable. We can also get a crop recommendation. This can be valuable for banks as well as farmers. So if a farmer is applying for a loan, he can first know how successful his venture will be, but the bank can also use the same tool to assess, is this farmer actually doing the right thing? And so we can see for this plot of land, the best crop to grow would actually be maize, so we can get more details. We have a soil nutrient analysis, description, and of course the analysis of the particular soil and the particular crop recommended. We can also have a yield potential, which is super valuable for banks especially. They can get a hard measurement of just how much money the farmer can expect to bring in by farming maize in this particular price. A combination of yield potential and the price, current market price, will tell the bank exactly that. And we also have a fertilizer recommendation. So, for example, if a bank or the farmer can both use this tool to first know, the farmer should know what type of inputs he is likely to need, and the bank as well can gauge what type of inputs the farmer is likely to need and the relative prices of those inputs. So it'll recommend different fertilizers based off of the soil content in that particular area.
While we've made considerable progress with the project, we still have a lot to refine and improve. One of our biggest ongoing tasks is expanding and refining our dataset for Tanzania. We greatly underestimated the complexities of working with satellite imagery. Mapping real soil data to its corresponding spectral image and constructing an accurate dataset has been far more challenging than expected. This process requires collecting real soil measurements from different regions in Tanzania, cross-referencing them with satellite spectral signatures, and ensuring consistency in our dataset. It is a critical step for improving our model's accuracy, and we are actively iterating on this as we move forward. We're also enhancing our user experience, particularly by improving our UI and SMS feature. Many farmers lack internet access, so making sure that they can still receive a personalized farming recommendation via SMS is a top priority. Additionally, we'd like to start working with Tanzanian agricultural agencies to cross-reference our results with the existing data. This will help validate our predictions, strengthen our credibility, and align our insights with national agricultural strategies. As we continue, we're excited to be working on a real problem whose solution could greatly improve the lives of so many. Thank you.